One of the earliest and simplest approaches is the procedural paradigm. This goes back to the 1950s with languages like Fortran and later C. The idea is straightforward. You write down a list of instructions, and the computer follows them step by step. It's like cooking from a recipe. First, chop the onions, then heat the pan, then fry until golden. The computer doesn't need to understand why. It just executes each instruction in order. This style is still incredibly common, especially in systems programming and embedded software. But as projects grew larger, developers realized that managing thousands of instructions this way quickly became overwhelming. That's where object-oriented programming comes in. Popularized in the 1980s with languages like C++ and Smalltalk, and later Java, Python, and C#, OOP introduced the concept of objects. Instead of one giant script, you create self-contained entities with both data and behaviors. For example, in a video game, you might design a player object, an enemy object, and a weapon object. Each one knows how to manage its own state and actions. This makes software more modular and reusable. You can take that player object and use it in another game with little modification. That's why OOP became the dominant style for decades, shaping everything from desktop applications to operating systems. But not everyone was happy with the complexity of OOP. Another school of thought focused on mathematics, leading to the functional programming paradigm. Functional programming avoids changing variables step by step, and instead emphasizes pure functions, code that always produces the same output given the same input without hidden side effects. Languages like Lisp, Haskell, and later Scala and Efforcia pioneered this model, and today even popular languages like JavaScript and Python have adopted functional features. The strength of functional programming is predictability and safety. Because data doesn't change unexpectedly, it's easier to debug, and it's perfect for parallel and distributed systems. That's why companies handling massive data sets, like in finance or machine learning, often lean on functional techniques. There's also a very different approach called logic programming. Instead of writing instructions or functions, you provide facts and rules, and the computer figures out the answers on its own. The most famous example is Prolog from the 1970s. Logic programming has been influential in artificial intelligence, expert systems, and natural language research, even though it isn't as common in mainstream software today. Closely related is the declarative paradigm. This one is about telling the computer what you want, not how to do it. The best known example is SQL, the language for databases. You don't tell the database how to look up data. You simply declare. HTML and CSS also follow this paradigm. You declare structure and style, and the browser handles rendering. Declarative programming reduces complexity because it hides the low-level details, letting you focus on the outcome instead of the procedure. As hardware advanced, another problem emerged: speed. Computers began to use multiple cores, and single-threaded paradigms weren't enough. That led to concurrent and parallel programming. Concurrency is about handling many tasks at once, while parallelism is about splitting a single task across multiple processors. Languages like Erlang and Go are designed around concurrency, enabling systems like WhatsApp to handle millions of messages simultaneously. Parallel paradigms are critical in scientific computing, AI, and large simulations, where processing power needs to be spread across dozens or hundreds of cores. Without these paradigms, modern large-scale applications would simply not function. Now here's the reality: most modern programming languages don't stick to just one paradigm. They are multi-paradigm. Python lets you write simple procedural code, but it also supports objects, functions, and even some declarative styles. JavaScript is the same. You can program it in an object-oriented style, a functional style, or a mix of both. This flexibility allows developers to choose the right mindset for the right problem. You might structure your web application using object-oriented design, then process data streams using functional programming techniques, and query your database with declarative SQL.